What's up friends, today we are going to be doing yet another DIY battery building tutorial. In this video we're going to be using some of my reclaimed 18650s to build a battery in a very different form factor to what we've done in the past. Stay tuned until the very end to see all the different techniques and this unique pack construction. Now, before we get started on the actual fun stuff and building this battery, I have to present you with this obligatory safety warning. Please do not skip this. It is very important. If you do any of these steps in this video incorrectly or differently, there is a chance that you could end up with a fireball on your hands due to things like improperly welding the cells, improperly soldering the cells, accidentally heating the cells too much, overcharging, over discharging, puncturing, mistreating, you name it. There's a lot of ways to ruin a lithium ion battery, but that doesn't mean you have to be scared of it. It just means that you need to respect it, take the proper safety precautions, and use the proper techniques in order to make sure you don't have a ticking time bomb on your hands that could turn it into a fireball any day. Our objective in this video is to show you a safe way to build a battery, and throughout the video I will be pointing out the different things that I do with my different techniques to make sure that the battery that comes out at the end is a safe thing to have in your board for hundreds or thousands of miles. Now, anyway, I will not be responsible for the things that you do with your batteries, but if you feel unqualified, we have a huge list of trusted battery builders on our forum that I will link down in the description for you guys to check out. Anyways, let's get on with the battery build. If this is your first battery build on my channel, welcome to the channel. If not, you might be coming from one of my old battery videos, which are still great and are linked in the iCard. Those two batteries are very different to the one that we're going to be building today, but there's still lots of good techniques in there that you will find useful if you haven't seen them yet. If you are enjoying my battery building videos, go ahead and hit that subscribe button because I've got two more interesting ones coming up in the kind of near future. Anyways, in this video we're going to be building a 10S 4P battery, and it's about time to show you what that looks like. Our first thing to talk about in this battery is the cells. Now, if you remember from the intro, I'm going to be using some of these Samsung 30Q cells that are actually reclaimed. Now, I know exactly where these came from and approximately how much they've been used, so I feel pretty good about using these in a pack to save some money. But as a battery builder, I don't really necessarily recommend that you go ahead and pick up a bunch of random 18650s and throw them together in a pack. It's generally not a good idea. You always want to use the same exact kind of cells with approximately the same age and the same cycle usage to make sure that your pack stays balanced for a long time and stays safe by keeping all the cells equally balanced. Now, there's a couple tools that you can use if you're going to reuse cells. One of those is a smart battery charger. With a smart battery charger like the one pictured on screen, you'll be able to discharge the cells to a safe voltage and then recharge them, tracking how much milliamp hours they take. Using this technique, you can figure out approximately how much capacity each cell has, and then using all those capacities and plugging them into a tool called repackr, you're able to have it automatically fill out a table of all the cells you're going to use and put them out in a way that should give you a much longer lasting battery than if you were to randomly spread them all out. Now, I've already put all my cells out in what I think should be their P groups, and we're just going to move ahead with the video, but I thought I would share that information with you in case you were wondering about how you should reuse cells. If you're unfamiliar with the general steps of how a battery build goes, this is how this one is going to go. First, we're going to arrange all those cells into their P groups. Then we're going to glue the P groups together. After that, we will add Fishpaper rings to all of the cells on their tops. Then we will wrap each P group in fish paper to keep it insulated from the others. After that, we will arrange the P groups into their series group, and we will make sure they all line up properly. And then after that, we will spot weld the nickel on all the cells, first the P groups and then the series connections. And then we will make our wired series connection, and then after that we will attach all the balance leads to the pack, And then at the end, we will make it all look pretty, organize all the balance leads, and finally wrap it up with some heat shrink to keep it safe. Now, our first step will be gluing the cells, so we're gonna go ahead and move on to that section of the video. Just before we go into the gluing, I want to show you guys this real quick. Before actually gluing the cells, I needed to prepare all of them for welding, and to do that I used a carbide cutter bit on the end of my Dremel to very carefully remove the excess nickel that was there from the previous pack. To do this, you use a very light hand and just touch the nickel to get it off of the cell. If you feel underqualified for this, do not do it, as you can easily cut through your cell. Instead, buy new cells or get them pre-cleaned from somebody else. In order to effectively glue all of these cells together in this odd pack configuration, I have 3D printed a little helper here that will effectively hold all of these cells together in the orientation that they're supposed to be in. And this will help me make sure that they all stay oriented correctly while I glue them. And we just have to repeat this a bunch of times and glue them all together. So I'll go ahead and speed through that for you guys. You can technically do this part whenever, but make sure to put Fishpaper Rings on top of all the cells before you get to welding. Now that all the P groups are glued together, it's time to insulate them properly. In this next step, we're going to be wrapping fish paper around each of the P groups to properly insulate them from each other. Some people say that you don't necessarily need to use Fishpaper Rings, but I think it's always a good idea to add them, and it definitely can't hurt. As for the fish paper between the groups, you technically only need to insulate the parts that touch, but I like to wrap the entire group. Now, before we get too far into this video, I want to show you a little bit about the pack construction. These lines that you see here are my enclosure constraints, so this is how small the battery needs to be inside of the enclosure. I designed around that. To make all of these connections into a 10S4P battery, we need to use nickel. In this pack, we're going to be using nickel for both our series and parallel connections. The reason we can do this is because I know for sure that the pack will not be bending in this side-to-side direction. Now, this nickel that we're using is 25mm wide by 0.2mm thick, and it should have plenty of current carrying capability. As for how the pack actually flows, we have our positive here and our negative here. And all of these serve as the series connections all the way across, except for the middle one, which will be a wire. I have a small picture here to show you of my layout to hopefully help you understand this a little bit better. In this picture, you can see all of the different cells, starting with 1, and then we count all the way up to 10. You can see the plus minus marked on each of them, and the nickel strips at the ends of each, connecting them all together. Hopefully that helps you understand the layout a little bit better, and we will be moving on. But I also have this special fancy divider that I'm going to print out and make it look extra nice at the end of the video. Alright, so we have all of the fish paper put on the P groups right now, and they're sitting here waiting for the next step, which will probably be gluing them all together. But I want to cut the nickel strip first before I do that, just because I want to be able to go through it quickly. So to cut the nickel strip, I need to make a bunch of pieces that will fit onto the sides here and connect them in both series and parallel. We're only going to have one series connection with a cable on this particular pack, and I'll tell you about that a little later, but it'll be between the 5th and 6th P groups. So I have this little paper template that I'm going to use to cut out the nickel strips, and this is basically just from a CAD design that I made, and put into a drawing and print it out. So I'm going to go ahead and cut all the nickel now, and we'll just speed through that real quick. We have now got all of the nickel strips cut, so 8 of these large pieces and 4 of the small ones. So it's now time to begin the spot welding and soldering process. First thing I'm going to do is go ahead and cut the wires that I need. The first strip that I want to spot weld on is the positive lead, which is going to be all the way over here. And for this one, I'm going to actually solder on the cable before we spot weld it, because I can solder it easily right in the middle and then spot weld it on all 4 corners. So we'll go ahead and start with that right now. In just a second here, we're going to be soldering this positive lead onto this piece of nickel. The technique we're using here is that we're going to be soldering the wire onto the nickel strip before we spot weld it onto the battery pack, because it keeps all of the soldering heat out of the cells. The whole reason for spot welding in the first place is to keep the heat out of the cells, and this definitely helps with that. For this soldering technique, what we're going to be doing is we'll be stripping back the wire, probably about 3/8 of an inch or so. We'll be pre-tinning it. We will rough up the surface of the nickel with my razor, and then we will pre-tin the nickel. And after that, we will just lay it on top and we're going to melt it together. These types of connections are very annoying to do, and it requires a pretty hot iron, and it makes it harder depending on what gauge the wire is. This wire is 10 gauge wire, so it's decently hard to solder. 12 is definitely a lot easier, but this shouldn't be too big of a deal. You'll notice that the flux mostly stays in the area that I roughed up, which is the goal for sure. For the cable itself, we want to make sure that when we're soldering cables like this, not to let the solder go too deep into the cable, because once it goes in there, it can get crunchy. And once it gets crunchy, that means it can break a lot easier. So we're just going to apply a drop or two to the end, and then we'll use the solder to fully tin this area. Alright, so for this part of the video, we're going to be doing a short welding montage. I've got quite a few welds on this pack, and I was actually welding with a new battery for this particular one, so I was tuning in my settings a little bit, and you might notice if you're experienced with this that some of the welds seem a little bit too hot. Some of them are, but it's okay. It'll be perfectly fine. They'll all hold well, and I'm pretty happy with how all of it went so far. So go ahead and watch this welding montage. In a pack like this, it's important to have all of the cells completely aligned before you start welding. So in this short little bit, you see me taping all the cells securely together with fiber tape and putting some glue on it before we move on to the welding. Now, in this step, we are going to be adding some magnets onto the nickel, and doing this just helps hold the nickel in place so I can align everything properly to get good welds. After welding on most of the normal cells, my next task was to weld on the weird series connection and the two power leads. You can see here there's a little bit of smoke coming off because there was a little bit of leftover flux on there, but this is the half of the series connection that I was about to solder to. As you'll see in this next clip, I'm going to be soldering this onto the number 5 series cell, and I had to do this in an odd way. First, I welded the other side of the series connection onto the battery, and then I gave it a little bit more tinning, and finally I went ahead and melted it onto the other side by holding it in my vise in a very awkward configuration. Now, I don't necessarily recommend other people do this exact path. You could easily do folded nickel here or change your pack orientation to avoid weird connections like this, but for me it worked and ended up being pretty clean in the end. As we close out the welding on this pack, I just wanted to let you guys know that the danger of the pack increases the more of these cells that you weld together. As you weld more series connections and put them all together, the potential energy of the pack increases, as does the voltage. So you definitely want to exercise extreme caution when welding the pack, especially towards the end. Make sure you're not wearing any rings or anything that can accidentally fall on the pack and short it out. As you can see here, I actually custom cut some more fish paper to go in between each of the halves of the pack. This is very important because if these halves were to touch at any point, it would cause a huge spark and probably ruin some of the cells. You can see here that I'm pre-tinning each of the spots where the balance leads is going to connect. And in just a second, you're going to see how I spaced out the pack so I could weld it properly. All these spacers in the middle are just keeping the pack halves separated so I don't accidentally short it out. we're on to the final step of welding, and again I'm using those spacers in the middle to make sure that the balance lead tin areas do not touch and create a huge spark. I had to weld these positive and negative terminals sideways like this just because I chose to do them last, because I was welding on the top and bottom of each of the P groups. Alright, so we are on to the next step, which is installing all of the BMS leads. Now the step can be a little bit daunting. I'm going to put a actual diagram on the screen here to show you what the wiring layout is going to look like. But basically what we're going to do is we're counting up from the negative lead on the BMS, the small black wire, and we're going to count up the cell voltages from the negative side. So this will be on the negative side of the first parallel group, which is opposite of what you would think. You would think number one would be the positive side, but number one is the negative side. Count up from there. So we see that we need to span our first cell. So our next lead will go to number one, which is going to be this little joint right here on this side. The next one after that will be number two, which is going to be this joint over here. And this one will go over there. The next joint will be number three, which is going to go all the way down here to this joint in the middle. And then number four will be even further down here on the outside. And that will be number five. And then the next one will be number six, which is all the way down the middle down here. And then it'll go down and down and down and down all the way till the positive, where we end with our final lead on the actual positive terminal. I'm going to lay them all out on here first before I cut anything, and then we'll go ahead and solder them all onto the pack. When I first started battery building, the balance wires were definitely the most confusing part of the entire thing, so I thought I would try and explain it a little bit more. In this diagram, the battery pack is laid out the same way that it's sitting on the table right now, and you can see all of the different cells. If we look at our BMS diagram again, you can see that it says first string for the first cell and second string all the way on as it counts up the balance leads. When you look at your balance connector, you're going to start with the negative lead being in the end of the one spot on that negative part right here. As you move up, you're going to count one cell at a time. So the first strand is here, the negative one. The next strand is going to be on this series connection. Technically, you want it to be on the positive of this cell, but since these two are connected, they share a common spot, so you can put it anywhere in between those two. And then as you move along, you keep connecting to each of the series connections. And each of those is going to be your cell number. So as you count up, the voltage gets higher and higher. So you can understand how I was warning you, as you get towards the end of the pack, a short across these two could be very bad. So that's why I have this big plastic divider between, as well as the fish paper, to make sure that it cannot short. And that's pretty much the end of this battery build. Now, this battery build was a little bit different from the ones we've done in the past in that we've got some nickel strips as series connections. And there's something you really need to keep in mind when you do this in a pack. and that is that you shouldn't ever rely on the nickel strips to do any load transfer. So you should build your pack in a way that it's rigid without putting any stress on those small spot welding joints. So this 3D printed backbone in here and the heat shrink together are going to do a really good job, along with the hot glue, at keeping this pack nice and rigid and safe. This pack is a little bit different, like I said, so if you have any questions or you're confused about something, feel free to leave a comment down below, or leave a comment if you like the video. I really like interacting with you guys. So we're gonna have some more battery builds in the future, and I've got some really cool DIY builds coming up. So if you are looking forward to that, hit the like button and give me a subscribe. Now, I don't really have too much else to say. I'm gonna play some footage of the heat shrink being put on the pack and then give you guys a nice little B-roll montage at the end. So I'll catch you guys around. Stay safe, keep on riding, and peace out.